MAXKGO is a new company in the world of drones, and this summer they're releasing this 4-in-1 ESC. In this video, we're going to take a closer look at it and do some real-world testing. This ESC sports 4S to 8S batteries with a continuous current rating of 70 amps, makes it a pretty powerful ESC, well, at least on paper anyways. If we take a look at the included accessories first, it's pretty much the essentials. You get two 12cm long 12-gauge wires and a male XT60 connector. Usually the XT60 comes pre-soldered, so I'm not entirely sure why they went with this approach. Maybe it's because a lot of frames now come with their own custom XT60 mounts. You get 4 nuts for the stack screws, a 35-volt 870 microfarad polymer capacitor, an 8-pin cable for the flight controller, and 4 gummies. The QR code included takes you to a web page with a clear overview of the specifications and the wiring diagram. So, to properly test this new ESC, I'm going to install it in a 5-inch quad. This is my daily driver freestyle drone, an Apex 5 frame with a Speedy B stack. I'm replacing the ESC with the one from MAXKGO, so yeah, I'm putting quite a bit of trust in this ESC doing its job properly. But first, let's take a look at the specifications of this 4-in-1 ESC. As I mentioned, it supports 4 to 8S batteries, with a continuous current rating of 70 amps and a maximum current draw of up to 100 amps. It uses a 30.5 by 30.5 mounting pattern, has a 32-bit processor, and runs AM32 firmware. As you can see, there's no heatsink on this one, so it'll be interesting to see how it handles things when it's pushed to the limit. The positive and negative pads are enormous, with small holes for the capacitor legs. The motor pads look a bit smaller than I like. They also have that small bend at the edge, which honestly feels more like a drawback than a benefit. The weight is 13.1 grams, a bit lighter than usual, which probably comes down to the lack of a heatsink. One thing I noticed when I went to check the price is that they actually offer a version with a heatsink as well. Without the heatsink, it costs $62 and for just $1 more, you get the heatsink included, which is probably a smart choice for this ESC. At this price, they come in quite a bit cheaper than other 70 amp ESCs on the market. So, let's replace this 55 amp Speedy B ESC with the new one from MAXKGO and see how it holds up. The MAXKGO ESC is a bit thinner than the Speedy B ESC, which actually works well on my Apex frame since it's quite low profile. Luckily, both ESCs use the same pinout to the flight controller, so I don't have to modify the cable. As I suspected, the motor pads are a bit tricky. Those small via holes in the pads make the solder flow straight through to the other side if I use too much heat. I'm using 0.8mm solder from Mechanic, since it's a great all-round choice for FPV, but in this case, a slightly thicker solder would probably have worked better. The holes in the main pads for the capacitor are convenient. They make it much easier to position the cap. On my Apex, I route the XT60 wires out to the side, so in this case, the rectangular pads actually work really well. They're also quite huge compared to what you see on a lot of other manufacturers. When you're using an ESC and a flight controller from different manufacturers, always make sure the pinout matches, so you don't end up with any surprises. The lead-free solder I'm using, combined with these slightly tricky pads, makes the soldering a bit more difficult than I'd like, and it's probably not my cleanest work. But as long as the solder joints are solid, I can live with them not being perfectly round and shiny. Now, a quick smoke test before I finish it up and take it out for a test flight. So, the MAXKGO 4IN1 is now installed in my Apex. For props, I went with the ones that have the highest pitch I've got, just to really push it as hard as possible. These are GemFan Hurricane 51 499 propellers, which should help push the current draw up quite a bit compared to lower pitch props. So, let's run a test and see how the ESC behaves under some load. Before this, I did a few gentle flights just to make sure everything works, and I've calibrated the current meter using Oscar Liang's handy calculator. Since I'm not a racing pilot, I'll try to put some load on it with a high camera angle and some punch-outs. The iFlight 1800 kV motors I'm running don't pull a crazy amount of current either. I've found out if you go into a split S from a bit of altitude and wait until the last moment before pulling out, it actually pulls a pretty decent amount of current. I tried to keep it above 50% throttle for this whole flight, but when I checked the temperature afterwards, it wasn't really warm at all. So, at least for a 5-inch build with this setup, it's looking good so far. Of course, I haven't been able to test it over a long period yet, so it's still too early to say anything about long-term durability. But if you're also interested in testing this 4-in-1 ESC from MAXKGO, I'll leave a link in the video description. At around $63 for a 70 amp 4-in-1, it would have to do a lot wrong not to be worth it.